Hello everyone, I'm Salman Ibne Eunus. So this is my 8th video of my basic robotics tutorial series. So today I will show you how to interface ultrasonic sensor with Arduino. So let's dive into the video. So as you can see, we are using this Tinkercad simulation environment. As you know, if you have watched my previous videos, so you already know that I've been using Tinkercad simulation environment for this whole tutorial series. So let's start. So this is an HC SR4 ultrasonic sensor, which is able to measure the distance. So if we get any obstacle, it can measure the distance. So before we go into the details of the circuitry, and let us know something about the sensor. So this is basically an ultrasound sensor which emits an ultrasound wave. So as you can see, there are two eye-like structures. So one is one is the transmitter, the T letter written, the one where T is written, this is the transmitter, and the other one is the receiver. So basically it transmits or emits an ultrasound of around 40 kilohertz or 400,000 hertz. So basically this sound is above the range of human hearing, so we cannot hear this sound, but it's emitting a sound, and when it gets an obstacle or gets when something comes into its path, so it bounces back and then returns to the sensor, and the receiver receives the reflecting ultrasound wave. So actually we calculate the travel time of the ultrasound wave using this sensor, and we use the speed of sound to calculate the distance. So as you know, distance is equal to speed times time, so we use that formula. So actually it has a maximum range of around 400 centimeter or 13 feet. So it will dissipate, or it will the wave will lose its energy after 13 feet. So it can actually measure the distance of maximum 13 feet or 400 centimeter. So actually it has a material, or this ultrasound wave is not affected by sunlight or any sort of light, and it needs a power supply of 5 volt, which you get from the Arduino. So for today we just need an Arduino Uno, a breadboard, and an ultrasonic sensor of module HC-SR4. So as you can see that it has 4 pins. So VCC, Trig, Eco, and GND. So VCC pin is, as you know from my previous videos, that VCC is for power. So it goes to the 5 volt in Arduino. So Arduino gives the 5 volt to the sensor, and also the GND goes to the ground pin of the Arduino as usual. So then we have another pin that is called Trig pin, that the pin which is responsible for emitting the ultrasound. So this basically triggers an ultrasound wave. So this is connected to the trigger pin is connected to the pin number 9, and echo pin is connected to the pin number 10, as you can see. So this is the basic connection. So the trigger and echo pin will go to 2 of the digital pins, as this is a digital sensor. So this will go to the digital pin, as you know. So since this is a digital sensor, so it will go to the digital pin. So the trigger and the rest will 5 volt, VCC to 5 volt, and GNT to GNT. It's like the usual connection. So let's go to the code now. This is pretty easy to interface Arduino with sonar sensor. So let's look at the code. So code, first of all, in the as you know that first of all, in case of Arduino programming, we first of all have to define our digital pins, analog pins. So we will define the pin number. So trig pin is 9. The trig is connected to 9, as you have seen, right? So we have written that trig is 9 and echo pin is connected to the digital pin 10. So this is also defined. So I have written the code previously actually, so that it saves time. So and then we will take two variable, this duration and distance. The duration is long variable, the type is long, and for distance it's integer. So then as usual we will have to define a void setup. We have to write some code inside the method void setup. So void means it doesn't return any value or variable. So if you have watched my previous video, I have covered everything. So pin mode, what does it do? It actually defines whether the digital pin or analog pin we are using as output or input. So as I have told you previously, that trig pin actually triggers the ultrasound wave. So it actually emits the ultrasound wave. So it is giving some output. The wave is given as output to the environment. So the trig pin will be defined as output, and the echo pin as it receives the reflected wave, ultrasound wave. So it will be defined as input. Then we have, as usual, to start the serial communication, we have serial.begin 9600. So I have explained in my previous videos what this 9600 means, and this is a built-in method actually. So this actually, the serial communication, actually defines the rate of transfer of data among the sensor and the microcontroller. So then we have, as usual, the while loop. This actually has the main code which runs in a loop and repeats every time. So first of all, since this is a digital sensor, so we are using the method digital write trig pin low. So first of all, we are making the trig pin low, which clears the trig pin. So I will explain this line at the end more clearly. So then I am using delay microseconds too. So as you know, the delay method actually creates a time gap between this passing of signals. So there is a new method delay microseconds. So 2 microseconds of delay I've used. Then I will set the trig pin high state for 10 microseconds. So as you can see, the delay digital write trig pin high. So trig pin is high for how many seconds? Trig pin is high for 10 microseconds. So delay microsecond is used. So as you know, when we in my previous videos, I have been using the built-in method delay, which actually was giving values in millisecond. So now this delay microsecond gives values in microseconds. So then I have digital write trig pin low. Then after 10 microsecond, I will make the trig pin low and will allow the reflected wave to come. So you see that then the trig pin is low, so then it will allow the reflected wave to come and will be received by the echo pin. So echo pin will read and return the sound wave travel in microseconds. So then I am using this variable which I have defined in the beginning, long duration. So duration value could be like a very large value, so we are using long here. So duration, we are again using a built-in method, that is pulse in. An echo pin is made high so that it can receive the reflected or echo wave. So pulsing method is used and echo pin is, as this pulsing method actually returns the sound wave travel, the time it takes for the sound wave to travel in microseconds. Then we will calculate the distance by using the formula distance is equal to speed times time. So here is one issue that you need to understand. First of all, we are calculating the, we are getting a value of for duration, but actually if you think that when when the wave is being transmitted, so it first of all it goes and then gets an obstacle and then comes back. So the time which we get from the echo pin is actually twice the real time, because first of all the wave goes and then gets and then if there is an obstacle, it actually hit the obstacle and then come back. So there is actually, we are getting the time which is twice the real time for the sound wave to travel. So for this reason, we are actually, what we are doing, we are dividing our duration value by 2 to get the real value of time, and then we are multiplying it by the distance, multiplying by the speed of sound. So as you know that uh, so it is actually 340 meter per second, but here we are taking 0.024, that is 0.024 centimeter per microsecond. See that our duration value is also in microsecond, and also our speed is also in centimeter per microsecond. So here the microseconds will be cancelled out from duration and the speed, and what will be remaining is centimeters. So we'll get the distance in centimeters, and we will just print, then we will use the serial.print to print the distance in centimeters, this text in a string, and then we will use another print statement, serial.println, print the distance value. So you have to be careful about the curly braces and the semicolons and everything. So this is actually the code, so I hope you understood the code. So let's start the simulation and let's see what happens. So this is actually a very good simulation environment made by the Tinkercad. So you can actually see the real scenario, although you're not using this sensor practically, but you can see the real scenario of what is happening, or you can at least get the intuition or learn what is happening. So for opening the serial monitor, we have used the serial.begin 9600 method. So let's see what the serial monitor shows. Serial monitor shows a distance in centimeter of 110. Why and how? Let's see. So you can see that there is a there is a simulation environment. So this ball-like structure actually shows an obstacle. So if we change the obstacle distance, so accordingly we get the distance. So when I move the obstacle far away, I get the reading of far away. So, and this is the maximum distance. If I go below the distance, it still gives, but practically it won't. So at a time, it won't give such high value. So actually 326 is here, still giving 326 on that part. Actually this is working on that part, because there is a maximum distance that can calculate. So if I reduce the obstacle distance, you can see below that the distance in centimeter is also reducing. It's now below 100. It's now below, and it's now around 26, and then It's showing now very when it's too close, it's actually showing a wrong value. And now it's 20, 22, 20, 50, 64. So it's gradually it will increase. So this is actually the how the sensor works and how you can see it in the simulation environment, like thinking that. So I hope you understood the code. So in brief, like we have defined the first of all we defined the trick pin and the echo pin, and then we have initialized the variables data types long and integer. Then we have defined the pin so that they're input output. And then in the void loop we have actually, so there is one thing which I want to explain, like, so what is happening, this code is running in a loop, so every time it will like happen and will continue until this will, so when it reaches this line, so it will go again in the top first line of the void loop, and then will continue. So let us see why this trick pin low was used in the beginning. So when we are making the trick pin high and for 10 seconds and making it low, and then we are receiving the echo pin, then we are actually getting a distance value. Then again we will, if we get any obstacle, we will make the trick pin high. So before we are making the trick pin high, we are ensuring that it's low for 2 microseconds so that there is no overlapping of the like transmitted and the reflected wave. So this actually ensures that there is no emitted wave from before, and so there is no, so it ensures that there is no interaction or overlapping between the reflected and transmitted waves. So it goes for superposition or something like this on the reflected and the transmitted waves. So this delay actually ensures that there is no superposition or overlap between the waves. So I hope you understood this well. Thank you all for your time, patience, and understanding, and please subscribe to my YouTube channel to get videos related to programming, electronics, robotics, artificial intelligence, data science.